Thank you everyone for coming today to today's Science Cafe on Parkinson's disease. So before we get started, I just wanted to provide a brief overview of the Clinical and Translational Science Collaborative. So the CTSC of Northern Ohio is a collaborative amongst Case Western Reserve University and its affiliated partners that includes Cleveland Clinic, Metro Health, University Hospitals, the VA Northeast Ohio Health System, Northeast Ohio Medical University, and the University of Toledo. The CTSC aspires to be a catalyst for high-quality clinical and translational science and transformative research to positively impact the health of those in Northern Ohio and beyond. So this is being accomplished through 5 key areas and initiatives. As you can see here, resources and services, workforce development, community engagement, health informatics, and clinical and translational funding opportunities. If you're interested in learning more, visit the CTSC website, and I'll share a link and a QR code for that at the end of this session. So I want to introduce our content expert today, Dr. Subramanian. He is an expert in Parkinson's disease, and he is joining us from the University of Toledo, where he is a professor of neurology, neuroscience, and bioengineering, where he also serves as the director of the Junior Faculty Translational Research Program. He's a member of the Parkinson Study Group and holds an extensive number of appointments and memberships in the field of Parkinson's disease. And so with that, I'll turn it over to you, and let me just share your slides.
Thank you all for coming. I appreciate the opportunity to share with you some of the things that I have been learning and working with the CTSC. As you know, we at the University of Toledo are the new partners with the rest of the group, and we're delighted to be part of the CTSC this year. And along with that team, I'd like to introduce some of the concepts and ideas that we've been working with the rest of the CTSC to develop a collaborative that would enhance our research impact on communities as well as in our field of research. So as a brief introduction, if you can move to the next slide, I want to share my disclosures. I have NIH funding, Department of Defense funding, as well as other foundational funding. I do have honoraria for different organizations, and I hold a US patent, and I have a small company called StereoRx. But none of these things are direct conflict with what I'm going to talk with today. So with that disclosure, we can move to the next slide.
You should be able to control your own slides as well.
Oh, yeah. Okay. All right. So this is the intro statement. So Parkinson's is the second most common neurodegenerative disorder, and its prevalence is increasing as America ages. Early recognition of Parkinson's disease is critical as we are discovering new ways to treat the disease and potentially mitigate its progression. In particular, the lack of recognition of early symptoms denies these patients the benefit of new research. And this is particularly problematic in the underrepresented and vulnerable minorities, such as African Americans, Hispanics, LGBTQ populations, military veterans, and residents of rural areas, where healthcare disparities are very rampant, and therefore recognition becomes problematic. Our discussion will center on solutions to this problem and bring translational research expeditiously to these vulnerable communities. This educational discussion is designed to bring new ideas, so I encourage people to stop and ask questions, or when we have these discussion periods, which intermittently will unmute you, you will get a chance to ask questions to me. Okay, let's see if I can move this forward. Doesn't seem to, so you may have to move the slides for me. I can see.
Is this the correct slide? I moved it forward.
Yes, it is. And, so I will start out with this video. It's showing a patient with, no, please play the video. It shows a video of a patient who is having classic features of tremor. You can see his left hand has this pill rolling tremor where his little finger is moving side to side, which is classic. And then the second feature, which is the finger tapping test, where the index and the thumb are made to touch each other, and the patient is asked to open it really big and wide. And you can see that he starts out with a normal speed, but then as he keeps doing it, it becomes shorter and there are interruptions. And this feature, which we call bradykinesia and decrement of the finger tapping test, is pathognomonic of Parkinson's disease, is the earliest sign that we look for as clinicians to see whether these patients have a hint of Parkinsonism. So again, for the clinicians out there who are watching this video and who are listening to the talk, the single best test that you can do is the finger tapping test. Again, asking the patient to do it in the full range, full expansion of the movement, and see whether there's decrement, meaning there's a reduction in speed or amplitude. And this is a very early feature of Parkinson's disease that will help refer the patient to a specialist. Now, you can also do it in other parts of your body, like in the leg. You can do the foot tapping, as you saw, where again, you would have some slowness of movement. Next slide, please. Oops, okay. And so what's new in the field is that we have recognized now that there are many more features other than Parkinson's tremor, which is very pathognomonic. People come to you because they see the tremor, and also because when the clinician does this, they can see the slowness of movement. But there are many other things that a general practitioner or public would recognize, which are harbingers for Parkinson's. One common symptom is constipation. 80% of Parkinson's patients have constipation. So that should be a red flag. And an elderly person, 60 plus years old, who's having constipation, one thing should go in your mind is that, hey, is this the earliest feature of Parkinson's that you're seeing? Parkinson's is not the only thing that causes constipation, but it should ring a bell in clinicians, in physicians, in nurses, healthcare workers of any kind, physical therapists, and even social workers, when they are seeing people and they're noticing that patients have constipation, then this should ring a bell and say, hey, maybe I should look for a little bit of signs of Parkinson's. Similarly, sleep fragmentation. And if patients are saying that sleep is not good, they're sleeping poorly, or that they're acting out in their sleep, they're acting out their dreams in sleep, then that's another very strong indicator that they are likely to develop Parkinson's or similar type of illness. For example, if you had REM behavioral disorder, which is acting out your dreams in your sleep, the rate of phenoconversion, the risk of you developing Parkinson's or Parkinson's-like disease is greater than 80%. So anybody who has dream enactment and REM behavioral disorder, it's a high risk for Parkinson's disease. And this should be ringing a bell into the clinician's head and community members' heads that, maybe this is something that I need to seek help, see a doctor, or see whether there's any new research that's available for people to participate in. Olfactory deficit, lack of ability to smell. This is not very specific for Parkinson's, but again, it's something that should be ringing bells to ask people to think about it. So the point is, there are all these non-motor symptoms that have nothing to do with tremor, nothing to do with slowness of movement, that can precede Parkinson's disease. And we have to become more attuned to this findings and see, hey, if you see these things, should we be considering Parkinson's in the differential diagnoses and have patients be referred for looking into research opportunities or not? Next slide, please, which I think is a break slide. Yeah, so I'd like to use this time to discuss and ask your feedback to see, what do you think are the ideas that you have in how PD, Parkinson's disease, can be recognized, and knowing that you're not looking for the classic tremor, you're not looking for slowness of movement, you're not looking for falls, etc. But you're looking for some of these things that I just mentioned, which is sleep fragmentation, REM behavioral disorder, acting out your dreams, and constipation or lack of smell. These are the key things that should trigger the idea that, hey, maybe I should look for that subtle tremor that maybe they didn't want to tell me about. So the people that I know that frequently see these people are family members, neighbors, family doctors, internists, nurses, physical therapists, chiropractors, social workers, and other healthcare workers, and many people who might be in this audience right now who might be seeing this. How do we do this, Mackenzie? Do we open up for questions or they just type questions? How do we do this during the discussion?
Yes, you either can unmute yourself or type your response in the chat.
Yeah, there's one question here. What about incontinence? So incontinence is a very late finding in Parkinson's disease. Typically doesn't happen in the early stages of the disease, unlike constipation, which is frequently precedes. It's a pre-symptomatic dysfunction. So incontinence is quite rare in that setting. But what we want to encourage today in the discussion is early recognition. How do we find people with early symptoms before they even come to the neurologist? Can community people actually recognize this earlier or not? So I don't see any questions or any hand raised or any unmuted questions. Let's move on, and then we have another break. So if you have more questions, we can talk about it in the next break. So let me talk a little bit more in the next slide about what else has been going on. So this is the pathology of Parkinson's disease. So if a person dies with Parkinson's disease and you look in their brain, you can see these pink inclusions that we see all the way into the right side. They're called Lewy bodies. They're formed due to abnormal misfolded proteins, which are called alpha-synuclein, and they're a phosphorylated form of it, which becomes accumulated and have this pink structure. Next slide, please. And this alpha-synuclein starts out as small individual proteins, but then they get misfolded, and this misfolded one accumulates with the neurons, causing the neurons to die. Next slide, please. And so research that was done about 20 years ago showed that these misfolded proteins are actually there not just in the brain, but it's there even in the gut. So here you see that the nerves that innervate the gut also have these alpha-synuclein. And a professor by the name of Dr. Brock showed that maybe the disease actually starts in the gut and then migrates to the brain via the vagus nerve. The vagus nerve are two pairs of nerves that come from your brain and go to your heart as well as to your stomach and controls the muscle contraction of your stomach. Next slide, please. So this is called the Brock staging hypothesis. He showed that the disease first spreads to the lower part of the brain and then goes to the rest of the brain, so-called Brock staging. The next slide, please. And we know that some of the things that trigger the gastric changes in the gut, is military exposure to toxins. For example, Agent Orange, paraquat, things that were used in the military services, rural living, because we have a lot of herbicide used in farms, well water drinking, because the pesticides does go down into the well water and to the groundwater, and head trauma, which again, very common in military exposure. Now, all of this is very common in the underrepresented population, and unfortunately, they don't get the healthcare because of the disparities. They don't come to seek healthcare in these circumstances. Next slide, please. So taking advantage of one of them, which is the paraquat, which is a herbicide that is very commonly used around the world, we decided to examine whether this can be tested in some animal experiments. Next slide, please. So we showed that in this experiment that we combined the paraquat with a small amount of a protein called lectin, which is also very common in food, and gave it to rats. These animals developed Parkinsonism. Next slide, please. So we showed that not only the gut has the initial change, but it transfers it through the vagus nerve into the brain, and that this is the reason why some of this disease might be happening. Next slide, please. So again, as I mentioned already, pesticide and diet, the combination of it, if it can produce the pathology in the gut and it can go to the brain, that can be something that we need to be looking for. Next slide, please. So we gave the sub-threshold dose, very small doses by itself. If you gave paraquat alone, nothing happened. If you gave lectin alone, nothing happened. You had to combine the two, and it had to be in a very small doses in order for it to produce the damage that we were looking for. Next slide, please. And so this is the method. We give it for a week and follow the animal for 4 weeks, and we look at the brain and look at whether there's any damage. Next slide, please. And we show here that clearly when the animals are given the paraquat and lectin, they became Parkinsonian. And then if you, before giving it to them, if you cut the vagus nerve on both sides, they are protected, as you see in the last 2 bars. And in the middle bar, you see that if you give levodopa, which is a typical treatment for giving for Parkinson's disease, these animals do get better as well. Next slide, please. So this is the model. The model shows that the animals can be preserved if the vagotomy is done, but if you don't do the vagotomy, then they do develop, and it shows that due to the toxicity of paraquat and lectin, they can develop. So this is an environmental model. It allows us to model what happens in humans, possibly, and cause the Parkinson's disease. Next slide, please. And when we look at the brain, we can see the appropriate pathology. We can see the alpha-synuclein, both in the vagus nerve as well as in the nigra. Next slide, please. So we showed this, we published this paper, and following this, next slide, we decided to extend this into treating constipation and progression of constipation, because constipation is a GI disorder, and therefore we decided to test this in a clinical trial. So the next few slides are going to be about the clinical trial, but I'll pause here if anybody has any questions or any discussion about what we heard so far. Again, you can unmute or you can type your questions, and I'm happy to answer. All right, seeing no questions, let's see if we can move to the clinical side. So it turns out that there is a dual-purpose small molecule called squalane. This is made by the dogfish shark, and it's a bile salt. And it turns out that this was being tested for constipation in cancer patients, especially colon cancer patients. And it turned out that this drug gave very good relief for constipation, but it didn't improve the cancer very much, unlike what the cancer doctors who were testing it with. So then we decided whether we can test this in Parkinson patients. Next slide. So this was a trial that we did, a clinical trial, open label trial on several subjects. And we show here that if we gave this squalane to patients with Parkinson's disease and constipation, they got their constipation improved. And in addition to that, you see here the Unified Parkinson's Disease Rating Scale, UPDRS, which is the first column, part 3, you see the baseline score of 35.4, and you can see that there was a 5-point reduction, which was statistically significant in this 34 patients, suggesting that if you just treated the constipation early and effectively, then they may have some improvement in their Parkinson's symptoms, which was quite unexpected. We didn't think that this would happen, but the patients actually got some improvement. And surprisingly, there was some slight improvement in their memory deficit also. It's very small, just a 1-point increase, but it seemed like there was some improvement there as well. Next slide. So based on this, we did a double-blind placebo-controlled trial, a multi-center trial, 150 patients with constipation. And again, we had this surprising, very interesting result that these patients got improvement not only in their constipation, but they also had improvement in their Parkinsonism scores. Next slide. And the most interesting thing was that in addition to improvement in constipation and making their bowels move well, they had improvement in their Parkinson score in a good majority of the patients. And also, they had improvement in their cognition and hallucination. There was a small number of patients who had hallucinations, but the small number of patients also had improvement in hallucinations, suggesting that treating constipation may actually have some long-term benefits. So in this slide, what's illustrated is 39 out of 83 patients on the left side who are on the squalane, they had improvement in their Parkinsonism, whereas only 11 out of 52 had improvement in their Parkinsonism when they were on placebo. Again, this is not definitive because the study was not designed to measure differences in Parkinsonism. It was designed primarily to address the question of constipation, which it did meet the primary endpoint, but the exploratory endpoints were actually quite interesting. Next slide, please. Which illustrates here the cognitive symptom improvement. Again, you can see that in 6 weeks, there was some cognitive improvement, and in hallucinations also, there was some improvement. This again is published. This is a multi-center trial that we did, and I was the lead principal investigator and the study director for this particular study. Next slide. So then that brings up to where all this puts us at the CTSC. So we are here that we know that we have the population here. We have a lot of underserved people, both in the Cleveland area and in Northern Ohio, extending all the way up to Toledo. There are many military veterans. There are many people with Parkinson's disease. And we certainly have patients with constipation and sleep disturbance. So what we want to design is to ask the question, if we can combine our resources and identify appropriate patients, can we then treat these patients with something simple as bisacodyl, Dulcolax, which we all use for treating constipation from time to time? Can we give this in a systematic fashion in a randomized placebo-controlled trial and see whether these patients will get the benefits that we got with squalane, or does this have to be much more sophisticated or not? In addition, we can use the identification of such a cohort for doing retrospective studies as well. So we just started doing this work, and I've had some conversation with people at the CTSC, collaborated with a number of individuals, both at the Cleveland Clinic and at University Hospital and at the Cleveland VA. And we have been working collaboratively to see whether we can identify cohorts of patients. So the first step to this, next slide. We have been working with Mark Beno, who has identified a way to do a pre-study study. And the idea is to use available databases, both at UH and the Case Western Reserve University, as well as the VA and Metro Health Hospital, to combine our IT and ability of our IT team to identify subjects potentially who could participate in such a trial. And the idea would be that if we find military veterans who have had exposure to pesticides in sometime in their lifetime, and they are now suffering from early features of Parkinson's disease, they have constipation, or they have sleep disturbance, whether they could come into the study, a double-blind placebo-controlled long-term study that would then ask for whether it can be answered. These questions can be answered in a study of such a design. We have just started the work, and it's been very exciting to work with the team. We have gotten some very good feedback from a number of individuals saying that this is low-hanging fruit, that we should be working together and get this addressed. And the hope is that this would generate a multi-center large trial, clinical trial, that we can submit to one of the agencies, either the NIH or the Department of Defense, and see whether this can get funded so that we can bring this type of research to our community, particularly the underserved communities, the Black, Hispanic, as well as LGBTQ plus, and military veterans and rural population that have very little access to healthcare, particularly to cutting-edge research. And part of the exercise today is to see how can we get early recognition happen? How can we get clinicians, physicians, other healthcare providers, nurses, physical therapists, chiropractors, people who would run into patients with these symptoms, early preclinical symptoms, how can we increase their awareness of early diagnosis and the need for early diagnosis so that appropriate referrals can happen for these type of studies. And that's the purpose. Next couple of slides are acknowledgement slides. These are just my team, people who work with me, my graduate students, my technicians, my clinical research associates. Next slide is people who have worked with me in the past, who have also contributed to some of what I presented today, both the animal studies and where we are going with the clinical studies and the testing that we do on our patients. That's all I have, but I'm very open to hearing from you all, questions, suggestions, things that we can do better and how we can make this into a successful program. I also want to invite at the end, after the discussion, Sue to come in and talk a little bit about the voucher program and how we can use the voucher to do some of these things.
All right. Well, thank you so much. That was really great. Sue, I don't know if you want to talk now before we jump into discussion.
We'll speak whenever it's appropriate for the flow, if now is good. I will talk. Well, what an amazing presentation. And I don't think we could get a better example of what the CTSC is doing in this iteration. So thank you very much for that. I'm Sue Morosco. I'm Associate Director of Program Development and at the CTSC. I wanted to tell you a little bit about the voucher program and some of the offerings for the grant development at the CTSC. So everyone on this call is involved in pushing the boundaries of research and making sure that this new iteration benefits people directly, which is exactly what a study like this is aiming to do. So the voucher grant is a proof of concept grant. It's $7,500 that recognizes that the collaborative partnerships need as much help as possible clearing barriers to getting the work done. So it's intended to help forge and promote those collaborations among amazing 5 dynamic and very different institutions across Northern Ohio, from U-Toledo to NeoMed to the partners here in Cleveland, and help with that clearing of any sort of barriers to support the collaboration as much as possible. So we also can help with the preliminary data among the institutions, making sure that data management is taken care of so that whatever's produced out of that $7,500 feeds these larger grant proposals. So the CTSC website is, a great catalog of services and support for clearing the barriers of this collaboration. And I want to also mention that we have Jerry Jewett-Tennant, who can help find you other collaborators and make that easier. If you're looking for a partner, you have the resources, but you need this to take care of things. Jerry's a great service for that. I serve as the subject matter expert on scientific and technical grant writing, proposal development, translational research. So I'm a great resource if you want to figure out how to make your project translational, maybe think about different aspects of how to get the work taken care of. We also work with a great number of community partners because we have amazing populations in Northern Ohio that can serve the research and serve as subject matter support. So that, in a nutshell, is what we do. And the voucher is meant for a quick turnaround to take care of things quickly. And I will put my email and Jerry's email in the chat, but I encourage you to follow the links to the CTSC website for all of the services available. Are there any questions quickly about that I can answer? Perfect. Well, I'll let you get back to the great research and I'll put my information in the chat. Thank you for the opportunity to speak.
Thank you. Thank you, Sue, for sharing that. I can share that my experience so far has been incredibly positive. I'm also an Atlas Fellow, and as a representative of University of Toledo and the Atlas program, which is the Advanced Leadership in Translational Sciences Fellowship. I'm completing that program in September. Anybody at U Toledo who is in the audience who wants additional information, you can certainly reach out to me, and I'm happy to serve as a liaison between CTSC and UT folks. But of course, anybody else who is interested in the topic, please do write to me or email me or contact me, and I'm happy to share what we want to do. And we certainly want to make this into a success. We do plan to submit research grants in relatively short order. And we would like to collect as much data and as much as possible. And all your help to make this happen would be wonderful. Other questions, discussion points. I see a few people I recognize. If you don't feel shy, please do raise questions or ask me questions that I can help answer. Or if you have some new ideas on how we can do things. Yes, you can type your questions here or ask them directly. Either way is fine. So I see one question from Jody, which is, for early detection, outreach to athletic clubs or personal trainers for training of early symptoms and referring. That's a great idea. Thank you, Jody, for that suggestion. That's not something that I've thought about. Yeah, certainly that's a great idea. And yeah, we'll certainly look into that and see whether that's a targeting. So right now we've been thinking about direct targeting. So we've been reaching out to Veterans Association and Organization of Military Personnel to target. We're also doing, as we said, doing the information technology-based searches. So yeah, so we've been doing those type of things, but that's a great thought to go to the physical trainers and see whether they would be able to recognize people. Great thought. Thank you, Jody.
About early recognition, Dr. Sub, is it clinicians don't know about these early symptoms yet? Or is it just lack of awareness in general about Parkinson's symptoms? Or what do you think that is?
Well, great question again, Jerry. Thanks for asking the question. There are two main reasons. One is benign neglect. So a lot of people, they have a little bit of tremor. It's blown off as age-related. And people say, oh, yeah, you're a certain age, so you're allowed to shake a little bit. And only when it becomes more problematic is it brought to the attention. And then the lack of access is a big issue. There are very few neurologists, number one. The proportion of number of neurologists to number of people who need a neurologist is big mismatches there. So oftentimes there's a long delay to get even an appointment. So frequently these type of patients bring it up or don't bring it up because they don't think they're going to get the care that they need. Or frequently, and I think this is the second most common reason, is that the healthcare disparity for the people who are really disadvantaged, such as African American men and women, Hispanics, LGBTQ+, even some military families, especially people who don't get veteran benefits, who had worked only for a short period of time in the military and they're not eligible for veteran benefits, or even veterans who have to wait a long time to get their benefits through the VA. They're all people who are in this group of people who don't get the care early enough. There is also the notion that Parkinson's is a very dangerous disease, and this diagnosis will mean that you're going to be in a wheelchair and you're going to be in a nursing home within 10 years, which is not true at all. So there's also a reluctance to seek care. Modern day care, people can live normal lives for as long as they are destined to live, and the disease itself does not increase your mortality. There is some inconvenience of taking medication, and with the availability of a lot of good treatments, the quality of life can be extremely, extremely good. So that fear factor, the fear that, yeah, I don't want to be diagnosed with this particularly nasty disease, is another reason why they don't get the care. But I think the top two are the lack of access to doctors and the benign neglect of early symptoms, saying that, yeah, it's not serious enough, I don't need treated right now, is the two reasons why I think there's early recognition is a problem. Now, I don't want anybody listening to this talk to think that we're encouraging treatment when it's inappropriate. That's not the point. The point is diagnosing it early gives them access to research, like the ones that I was mentioning, where we will be able to provide drugs that can prevent disease progression or avoid the disease from getting worse. And participating in research, especially rigorous, placebo-controlled studies or good cohort studies that are very rigorously designed, will help us advance the care of patients. And if we don't recognize it early and bring them into the research fold early, we're never going to be able to answer these questions. So the point of today's discussion is not for inappropriate treatment early, but early recognition so that you can encourage people to be part of research and bring in some of these disadvantaged communities back into the fold of the research, and therefore expanding the knowledge base that we have. That's the point of today's discussion. I hope I answered your question, Jerry.
You did, yes. I see another one in the chat too.
Yeah. Just curious, has there been research done modeling time to event as a function of symptoms? There would be some hanging over of the entry point, but these details could be debated later. Yeah, it's a perfect question. In fact, this morning I had my lab meeting and we were discussing this exact point. So this gives me an opportunity to talk a little bit more about the model that I was talking about. In the rat, at least, we had first tried the 7-day exposure to paraquat and lectin. So the 7-day model, we were examining in different cohorts. The first cohort, we thought, okay, at 4 weeks, we saw all these animals becoming Parkinsonian. But it turns out in subsequent studies, and the latest study that we have yet to publish, but we're getting ready to publish, we see that if we keep the animals for longer periods of time, up to 16 weeks, which is 4 months, as opposed to 1 month, we kept it up to 16 weeks, which is 4 months. We see that there is a gradual progression of the events. So animal starts out with just one side of the body affected, what we call hemiparkinsonism. And then over time, the animals start developing more symptoms, and eventually they become affected on both sides. So if you wait long enough, you see the time to even progression. So when does the first thing happen? When does the second thing happen? When does the third thing happen? Like that, we can see time to progression. So it's a very interesting model. And as the questioner was asking, this allows, as Phil was asking, this allows us to do interventions at different time points in the animal model. So we could say, okay, somebody's diagnosed with just one side is affected. So the rat is only affected on one side. Can we intervene there to see whether you can prevent it from getting any worse? And that particular model is very interesting because, after all, if a patient is suffering and they are affected only on one side, they're hemiparkinsonian, can you prevent it from getting onto bilateral or not, would be a very interesting model. So yeah, Phil, your question is right on the money, and it's something that we are really interested in pursuing, both in the animal model as well as in patients. Zhao L asks, is there any community awareness education about PD existing? Yes, there are some. There are patient organizations such as the American Parkinson's Disease Association, APDA. They have periodic events that they hold. The Parkinson's PDF, Parkinson's Disease Foundation, is another foundation that holds such events. But these type of events were common before COVID. And after COVID hit, the community engagement events became rare because of the limitations that were imposed by COVID. It's slowly building back up. People are getting together and doing things again. But this has become a real problem. And now we are in a technology Zoom era where we're doing all these events in Zoom. And that's challenging because communities that are less represented, they don't have access to the technology. And elderly folks are not technology savvy as the younger folks are. So as technology keeps changing, Zoom, whatever else is happening there, Google Talk, other tools are there, it becomes harder and harder to make this face-to-face, person-to-person contact come together. So there is more need for community engagement talks, and educational talks are needed. And I think hopefully CTSC will help us do this to a greater extent, because that's one of my understanding is that's one of the goals of the CTSC, is to take research to the communities and make them aware of these as well. Mackenzie or Jerry, you have anything to add to the community engagement question?
I don't know, Jerry, if you have anything you'd like to add.
I'm sorry, I'm actually sick at home, but I missed that question.
Oh, it's okay. I think I answered it, but the question was about community engagement and how we can make community engagement happen regarding educational math. So again, let me take the next question, which is here, which is again from Phil. I'm a mathematical statistician who does a lot of work in novel multivariate statistics with respect to human microbiome. Has there been research done rigorously comparing PD patients with non-PD patients in terms of microbiome composition for specific cohorts, example, veterans? Great question again, Phil. This is a very hot subject in the arena. And yeah, you asked about patients. Yes, there's a lot of studies going on looking at gut bacteria microbiome and comparing it between PD patients and non-PD patients. Clearly, the gut flora is different, no question about it. There's data that microbiome does influence PD. One particularly interesting experiment, which has been difficult to replicate, but very interesting experiment, was that they took the feces from PD patients and did a fecal transplant using that into mice that were vulnerable for Parkinson's disease, and showed that just doing a fecal transplant made these mice Parkinsonian. This experiment was published about 2.5 years now, almost 3 years now. It's not been replicated, but was some proof of concept that maybe such a thing exists, that there are gut flora does influence the effects of Parkinson's disease or the causation of Parkinson's disease. So that's a answer to the first part of your question. The second part, whether it's been done in veterans, whether the veterans with Parkinson's and veterans without Parkinson's, that the gut flora has been compared. I'm not aware of such a study, but that would be very interesting and potentially an interesting concept to look at, especially with the kind of statistical tools that you're talking about, multivariate statistics, to look at whether the different types of microbiome have differential effects on it. As a sidebar to your question, we are doing this exact same experiment right now on the rat model. So we're looking at the microbiome in the rat to answer that type of question. So, and Jerry, you had something to add there. You have posted about the community stakeholder engagement. You want to talk a little bit about that?
Jaleese is really our expert in this, but we do have a module that is community stakeholder engagement, and that is all about involving community groups or community in general into your research. And we have consultations that we can do for that as well for our researchers.
Beautiful. Thank you so much for adding that to the discussion. Thank you, Phil. Appreciate you participating actively.
So I was curious if anyone who's, on the call right now would be willing to kind of talk about why they joined the Science Cafe today, or talk a little bit about, what space of research they're in regards to Parkinson's disease.
I'm a movement disorder clinician at UH, Steve Gunsler, and I'm interested in the work going on regionally here in northern Ohio, and we've had a similar challenge. We've been looking to recruit prodromal PD or early PD for biomarker studies, and RBD, for example, REM sleep behavioral disorder, which is common precursor to PD, has been very hard to recruit. I think we've found only a handful of people to volunteer for our biomarker studies. So, a regional approach is an interesting suggestion for identification, especially of the prodromal cases, which would require primary care engagement and maybe sleep centers and maybe patients seeking care for constipation, but also early PD. You're right. I mean, we don't see. I don't see that much early PD. I see a lot of people with Parkinson's disease, but most of them have seen the primary care physician for quite some time, and then books an appointment 4 months in advance. And there's a process to making your way to a subspecialist, and you may or may not see a general neurologist in the community, and then they filter their way in. So definitely reaching out to primary care, which we've started to endeavor to do that for clinical studies, is at least educate primary care physicians, but also kind of look for technology-based solutions for primary care to identify, potential study participants.
Perfect. Beautiful. Thank you so much for making those comments. You read my mind, and that's what I was talking about. So I think we can relate to where we are, and we all struggle with the same issue. How do we get to the patient at the very earliest stages of the disease? And it takes a while for them to get to us. And by the time they get to us, we already missed that opportunity for us to do some intervention. So yeah, exactly. That's exactly what I think. So maybe we should, like-minded people, we should start working together. So
I'd be happy to discuss. So a very, very interesting talk. Thank you.
Great. Thank you so much. Yeah.
I don't know if there's anyone else who's on the call that would be willing to either unmute or share in the chat about their research. I'm not seeing anyone or anything in the chat. I don't know, Sub, if you have any other questions you'd like to pose. I know in the past, some people have discussed a little bit about current funding opportunities. So I don't know if you're aware of anything you'd like to share with the group.
Yeah, so there's a lot of very good, interesting funding available. There is the NIH Brain Initiative, which has got some interesting opportunities. The Department of Defense has some interesting funding opportunities for Parkinson's disease and related disorders. Also, the Alzheimer's disease and related disorders has some overlap with Parkinson's disease, for example, Lewy body disease. And there's some funding for the National Institute of Aging that there's overlap in that area as well. Great areas to get funding. So if there are junior people who are listening to this, who are thinking, hey, what kind of research I want to do, I would strongly encourage you to think about participating in Parkinson's research. We do need young, interested brains to come and work in the area, come up with new ideas, brighter ideas, and creative ideas to solve things. So I'm sure all of us, including people who are already engaged in research would encourage people, especially the younger generation, to come in and participate in the research. So I look forward to all of you seeking some of these opportunities and combining together to come up with some new answers.
Great. I don't know if you have anything else you'd like to add in the last few minutes, or anyone else has any comments or questions.
I want to thank all of you. Oh, there's a question here. Let's see. Okay. So this is from Madhu Reddy. He apparently was not, he's one of my students, and he's interested in the pathophysiology of Parkinson's disease, especially in autophagy. He's currently working on the specific molecule linked to the chaperone-mediated autophagy and see how alpha-synuclein aggregates are affected. But this has been a great talk, thinking about the critical point of view, clinical point of view. So yeah, he's one of our M1 medical students, one of the bright minds who's been working with us on this area. So I'm hoping that he would also take it up when he eventually graduates and to become an independent researcher and start working in the same area as well. I want to thank everybody, especially Mackenzie, for hosting me for this talk, and Jerry and Sue and others who have been here and helped me all along. It's been just wonderful. Being an Atlas Fellow has also been very helpful to me. And so I want to thank everybody. Also want to thank the audience, everybody who came in at lunch hour and spent a quality hour talking to me about this. If you have other ideas, thoughts, please email me or get in touch with me through We Have Mackenzie, and we'll go from there. Thank you very much. Appreciate it.
Great. Well, thank you so much for taking the time to present your work. I just wanted to throw this slide up here at the end with a few QR codes. So on the furthest left side, this is to register for next month's Science Cafe, which is on rural health with Dr. Schumacher. That's on August 8th. The middle is so that you can provide feedback about this session. And there's also a space if you have an idea for a future Science Cafe. And then the last is a QR code so that you can become a member of the CTSC and to be able to stay up to date with events and things that are going on within the CTSC. So if there are no other closing comments or questions, I will let everyone go, and thank you so much for joining us.
Thank you so much. Appreciate it all. Take care. Bye-bye.